Hello, Algebra 2 students. Would you believe I just went through your whole lesson and taught that whole thing, and for some reason it did not record. So we're going to try again. Okay. I don't want that one. I want this one. All right. So today we're looking at properties of logarithms. If you will use Desmos Scientific Calculator, that works really well with here instead of Desmos Graphing. If you go to desmos.com. Instead of Graphing Calculator, go to Math Tools up here at the top and click Scientific. To get to logarithms, you go to Function right here. And here's this key for log. If you needed natural log with a base of e, it's here. This is log. And your first one, I think, is 0.5. No, it's log 5, sorry. Would round to the nearest tenth is 0.7. Okay, and then you have one that is log 50. It's going to round to 1.7. And then you have log 100 is 2. All right, let's go back. No, I don't want the key. I want this one. Okay, so maybe I'll do a better job this time than I did the first time since it didn't record. Okay, so what we found using the Desmos Scientific Calculator was this. That log 5 is 0.7, log 50 is 1.7, and log 100 is 2. What I would like for you to do is stop the video for just a minute and fill in that middle column, log 5,000, log 500, log 250. Do the same thing we just did. Technology is going nuts on me this morning. Okay, so log 5, log 50, log 100. Go down, fill in the middle column, and then turn the video back on. Okay.
1 sec.
Hopefully, you fill these out. If you round these to the nearest tenth, this is what you get. Now, we can use these logarithms that we found at the top and the properties of logarithms to figure out what is log 5,000. It says to rewrite 5,000 in terms of 50 and 100 and 5. So they did 50 times 100 because 50 times 100 is 5,000. What is log 50? Log 50 is 1.7. This log 100 is 2. What do I do with those two to get the 3.7 that's in the middle? You add. Log 500 is 5 times 100. Just rewrote 500 as 5 times 100. Log 5 is 0.7. Log 100 is 2. What happens when you add those two? You get 2.7. It's in the middle. What about log 250? I can write that as 50 times 5. Log 50 is 1.7. Log 5 is 0.7. What do I do with those to get 2.4 that we found in the middle? You add. So multiply goes with that. It's kind of like our exponent rules. Multiplication and addition go together. Now look at log 20. We can't multiply any of those three numbers, that 5, 50, and 100 to get 20, but we can divide. 100 divided by 5 is 20. Log 100 is 2. Log 5 is 0.7. What do we do with those two numbers to get this 1.3? We'll subtract. Log 2, we can't multiply any of those three numbers to get 2, but we can divide. 100 divided by 50. Log 100 is 2. Log 50 is 1.7. Look what happens if you subtract. You get the 0.3 that's in the middle. Very interesting. Log 10, we can't multiply any of those three numbers, 5, 50, and 100. We can't multiply those to get 10, but we can divide 50 divided by 5. Log 50 is 1.7. Log 5 is 0.7. And if you subtract those, you get 1. Okay. So this is what patterns occur, what rules can you develop? From this, we can see that multiplication goes with addition and division goes with subtraction. Okay. Do your same thing. Take your Desmos Scientific Calculator and fill in the middle column, log 25, log 125, and so on. Okay, hopefully you got this. 1.4, 2.1, 2.8, 3.5, 4.2. Now notice over here they have 5 squared, 5 to the third, 5 to the fourth, 5 to the fifth, and 5 to the sixth. Okay. Log 5 is 0.7. What do we do with 0.7 to get this 1.4? Multiply by 2. What do we do with that 0.7, which is your log 5, to get 2.1? Multiply by 3. 0.7 times 4 is 2.8. 0.7 times 5 is 3.5. And 0.7 times 6 is 4.2. Where else do you see these numbers? Those are your exponents. Okay, those are your exponents. So those exponents, we multiplied. So 2 times log 5 is 2 times 0.7, which is 1.4. Move this exponent to the front. 3 times log 5 is 3 times 0.7, which is 2.1, and so on. So your multiply goes with add, divide goes with subtract, and your exponent becomes a multiplier. You move it to the front and you multiply. Okay, this is a summary, our properties of logarithms. So here, x and y are called the argument. What's done with this x and y? They're multiplied. Product goes with sum, multiply goes with add. So you have log base b of x plus log base b of y. In these two, the argument or the x and y are divided. Divide goes with subtract. So you have log base b of x minus log base b of y. Notice the base, that's b, that's in the subscript, did not change. The next one says the log of a number raised to a power is the same as the power times the log of the argument. So we're going to move this p to the front and make it p times log b of x. Okay. It's just summarizing the 3 properties that we discovered on the first page. These two, notice that the base and the argument, or the number or the letter that's in parentheses, are the same. I'm talking about this b is the base, this b is the argument. They're the same. When that happens, these two basically cancel out, and your answer is the exponent. Look here. The 2's cancel out. Because if we were to write that one, start with a base, raised to the power of x equals 2 to the power of 6, then we know, we recognize that as the bases being the same, set the exponents equal, right? So basically, when your base and your argument, or your base and your number that's in parentheses are the same, they cancel out. This exponent's understood to be a 1. Those cancel out. This exponent's understood to be a 1. Those cancel out. Okay? All right, next. These are sample problems. We're going to run through these, and then you have practice problems as your assignment. All right. Try these first without a calculator. If you know your properties, you can do these pretty quickly. If log 2 is 0.30 and log 450 is 2.6, so these are the two logs that you know. And we want to find out what's log 900. 900 is 450 times 2. 450 times 2. What goes with multiplication? Addition. So this is going to be log 450 plus log 2. Log 450 is 2.65. Log 2 is 0.30. Add those together. Okay. Letter B, same thing. We're going to see if we can combine the two logs that we know to make this 66. What do we know? We know 6 and 11. 6 times 11 is 66. That means we're going to add. What are we going to add? This and this. Letter C, what do? We have 36 and 3. What do we do with that to get 12? We divide. What goes with divide? Subtract. What are we subtracting? 1.6 and 0.5. The last one, if log 11 is 1.04, what do we do with 11 to get 121? 11 squared is 121. So I have log 11 squared, which means I'm going to move this to the front. 2 times log 11. Log 11 is 1.04. Okay. Using the properties. If you know those properties, it's faster than calculator. Rewrite each as the logarithm of a single expression. Again, we're using multiply goes with addition, divide goes with subtraction. Letter E, those are added. Those two logs are added. See the plus sign in the middle? So I'm going to multiply. 2 times 5, which is 10. These are subtracted, so I'm going to divide. 500 divided by 5 is 100. Make sure you keep the word log there. It's not just 10 or it's not just 100. It's the log of that number. Letter G, they're subtracted. What are we dividing? Subtract goes with divide. Divide x divided by 10. In letter H, you have this number out front that's multiplied. Remember, that came from the exponent. So we have log base 3. Oh, I forgot this base 5. When you see this little base, it doesn't change. Okay, it doesn't change, so you want to leave it the same. Log base 3 of x plus 1 squared. And log 2m to the 4th. That 3 that's in the front becomes the exponent here, which makes it 2 to the 3rd is 8. Multiply these. Easy peasy. All right. A little bit more. Remember, if the base and the argument are the same, these 5s are the same, your answer is your exponent. So this is 7. Argument and base the same, that's 1. This base is understood to be 10 because it's not written. It's negative 4. This one, we have addition. Multiply 3 times 4. Those cancel. We have 1. All right. So your assignment is your practice problems. You can use log properties. You can use, I'll tell you, the scientific calculator will not do these logs that have a base other than 10, but the graphing calculator will. All right. Work these for me. Send me a picture. Have a wonderful day.